All is well, everyone. Today in our Mahindra University, we have a one-day workshop on thermal battery management, and it is conducted by the Department of Mechanical and Aerospace Engineering. So let's get it.
So we try to bring back the Flex 1.0, what we have the world's first 100% battery electric and demo. Okay, we have made the battery thermal management in some extent that it supports both. I have on the side here, this side I have NMC and DO, and also we have the electronics, and this is the liquid cool die. You see that the coolant going across.
All. So we talk about serial hybrid, but this has been in the locomotive for a long. So it has a diesel engine which will run as a generator. That generator actually gets converted into AC or DC voltage and then fed to the traction. So that's we run for long time. Oh, okay. Yeah, yes, definitely.
Yes.
Thank you. So I think we are behind schedule, but
Okay.
Putsu trazer.
Touch upon this before going for battery level. Here, lithium ion cell, how it works. Lithium ion cell having majorly four components. How to pass this test and how to mitigate, how to isolate the cell. Isolation of the thermal runaway cell. Generally thermal runaway happens in one cell only, but that propagates to other cell. If we have major components here is charge discharge rates and AFP and microcontroller. AFP the battery, we it's called as a full board. In that case, we have two layers, one above the other. But in this case, we have only one full board where we get mount on under the legs. So here we are getting more 160, 180 more than. If you see the cost also, it's 50% compared to the cost. So we reduce like this by increasing the energy density. So energy density is very important parameter for the battery, even for the cost, weight, and other things. With the discharging. Not discharge with the charging only, that would normally autos they charge in the night overnight. So overnight only temperature will be -1, -10, -20. In daytime we don't see that temperature. So that only we are trying to manage it to -10, 0 degree and charge it instead of -2. So key focus areas to design the battery, advanced cell technologies, and the cost is very but the major components are anode, cathode, electrolyte, separator. And if you see, we will talk about the one by one component. How I think I have different stages. Right? One stage you can include only smoke. Next to propagates. So application we can solve, or 5 we can solve, but it goes for thermal runaway and it gives only smoke. Prediction of thermal runaway is not possible, but thermal runaway happens, we can if you
You have to predictive machine learning, and you guys can come up with a proposed model. We have next presentation from Professor Narendra Kurra. So, Professor Kurra is a faculty in the Department of Chemistry at Indian Institute of Technology, Hyderabad. So he earned his master's degree with gold medal from University of Hyderabad and PhD from JNCASR, Bangalore. He held a postdoctoral and faculty position at KAUST and Drexel University, USA. So before joining IIT Hyderabad, he worked at IISER Trivandrum. He has received 2021 and 2023, and recently he has secured the Research Excellence Award at IIT Hyderabad 1 week back. 1 week back. Thank you. His research focuses on majorly nanomaterials for electrochemical energy storage, including on-chip energy storage and hybrid capacitors. So, in the context of clean energy transition demands from the deployment of renewable energy resources that are abundant in our environment, electrochemical energy storage technologies such as batteries plays a crucial role in this aspect. So today he will be discussing about lithium-ion cell chemistry and operating mechanism, various polarization losses that leads to internal heat generation in the cell, and the failure events such as thermal runaway. He will be outlining some of the fundamental issues associated with various cell chemistries. So let's welcome him, and we shall now go into this talk. Thank you. Thank you.
Thank you, Professor Manish, for your kind introduction. Also, firstly, I would like to thank Professor Master and Manish for inviting me here. So, as he introduced, I just get started. That I'm going to discuss about cell chemistry because I come from chemistry department. So, things like we always look for the motivation. So, here is the motivation. That in the year 2015, United Nations formulated 17 Sustainable Development Goals. Like you see, goal number 1 is like no poverty, goal number 2 zero hunger. The idea here is to bring the peace and prosperity to humanity and the planet Earth. Okay, and in the year 2019, Nobel Prize was awarded to like Stanley Whittingham, Akira Yoshino, and John Goodenough for their kind of groundbreaking experiments in lithium-ion battery technologies, and they kind of changed the recharge of the world. And now to move on, of course, we are seeing that different battery chemistries are emerging, like especially the cathode materials, because cathodes are the weakest of anodes. You get good capacity. These are called Achilles and cattle. The GE, they are the kind of dominating industries that they're making. Of course, there are certain advantages using battery powered electric vehicles, and at the same time, the more thing is the which one?
Thank you, sir.
And we will have one group photo with all the participants.
ఏంటండి
Are you ready? Please, please.
మినిమం 25-30 సిస్టమ్స్ ఉంటాయి కదా.
You are speakers, please. Industry. We need funds from you.
We talked about mobile energy storage, the mobile application. Is we talk about the energy storage for the grid scale energy storage. So Dr. Abhishek Ranjan is a faculty in the Department of Mechanical Engineering at Mahindra, where he teaches fluid dynamics, hydrodynamics, and convective heat transfer at both UG and PG level. So before joining IIT Bombay, he was a postdoc at Engineering Department of University of Cambridge, where he also completed his PhD on numerical simulation of turbulent flows under rotation. So his doctoral research was fully funded by the prestigious Dr. Manmohan Singh Scholarship Award awarded by St. John's College. He has a MS from IIT Madras. We all know that he is alumni of IIT Madras, and BTech from NIT Jalandhar. Before, he also worked at Tata College, and his primary research interest is in engineering application of MHD such as liquid metal batteries and aluminium reduction cells. So we are gonna see some key concepts and key principles of liquid metal battery, which is kind of a new type of battery which we are gonna take some insight from him. Thank you. Welcome again. Thank you.
Thank you for inviting me, keeping you awake after a good lunch. So let's see how successful I am in that. So the picture here shows the battery pack made by a company called Amri. It's a spin-off from MIT. Professor Donald Hathaway in MIT has done a lot of work in this area. So this concept is called liquid metal battery. It's like it is a battery. It also is used for storing energy. But here, the idea is to use liquids, and in this case, conducting liquids, as the electrolytes and as well as also the electrodes. We have been heating the plant a lot, and that has resulted in many extremes. I'll show something more on this. This is not a major thing that we have been doing.
Not really. This is Dr. Mahindra, graduated in lot of since he is the first student and we were in the initial stages of EV thermal management, we told we'll make him do everything. So we started with thermal management, then looked at aging, then also thermal running. So he did all the work without complaint. I don't think he made a complaint. So yeah, he joined into 2020 July, August, and then graduated in 24. So 3.5 years finished the work, good reviews, good publications. And, he joined Ola Battery Innovation Center. So
Thank you so much, sir. As Professor Bhaskar mentioned, I am a student of Professor Bhaskar and I work with Minister Bhaskar sir. So we work both on thermal performance and chemistry, and after the thermal performance, it's going to be like over a period. Cooling method we can use for the cooling mechanism. The heat generation is very minimal. So there we can use of two different aspects. One is ambient air. We can flip it down. We can directly supply over the battery.
okay. Come Abhishek.
So once the interview starts, they ask me for technical
Based on that angle. The extension you asked, okay. You have 2 minutes. Do everything. You have to do the same thing for these components. Everything is allowed. Do everything. You have to do the same thing for these components. Everything is allowed. Yeah, eBay is a bit far, but robo.in you will get. Huh? 20,000? Huh? Okay. Okay, don't laugh. These pipes are RO pipes which are used in the home. Right? Plug and play, no leakage. 5 bar.
Temperature difference, the fluid flow takes place whenever there is a pressure difference. So to build up the pressure, we need pump. This temperature, pressure, flow rate, heat flux. So these are the measurable parameters. The derived parameter will be your, whatever the heat generation rate and all this will be the derived parameter. With the help of using mathematical formula, we can actually do the derived calculate for the derived parameter.
once this will be our next step is to from the lab view we wanted to get a DAQ. So once that is done, we're gonna take another step. We're right now doing the process of lab view.
So what we realized as part of this experiment,
This is
using,
around
and then formulate the equations and then put it in this.
this 2,500,
You have to
3,000.
make sure our equals are well known, our formulas are well known, and then
From a local person.
అవన్నీ యూజ్ చేసుకుని ఫుల్ ఆల్మోస్ట్ అది డెవలప్ చేయాలి అనే ప్రాజెక్ట్. సో వీటన్నిటికన్నా ముందు మెయిన్ మనకి పవర్ కదా ఇంపార్టెంట్. సో మీరు ఎక్కువ పవర్ ఎలక్ట్రానిక్స్ ఫోకస్ చేస్తారు. అన్నీ స్టార్ట్ చేసాం, అది తిరుగుతుంది. తిరిగినప్పుడు వెంటనే పవర్ కూడా జనరేట్ చేస్తుంది, రీజనరేటివ్ లాంటిది. సో మనం మామూలుగా ఒక చిన్న స్టార్టర్ మోడల్ తీసుకుంటాం, ఆన్ చేస్తాం, బ్యాటరీ నుంచి ఛార్జ్ తీసుకుంటే డ్రైన్ అయిపోతుంది. కానీ ఇక్కడ ఇది తీసుకుంటుంది, రీజనరేట్ కూడా చేసి దాన్ని ఛార్జ్ చేస్తాం.
So guys, how was the workshop?
వర్క్షాప్ మాత్రం చాలా బాగుంది. అంటే మాకు బ్యాటరీలో ఎట్లా ఆప్టమైజ్ చేయాలి, హీటింగ్ ఎట్లా ఉంటుంది. మనం ఎప్పుడు వెహికల్ చూసేదంటే ఎట్లా అంటే బ్యాటరీ జస్ట్ రన్ అయితే ఉంటుంది, దాని లోపల ప్రాపర్టీస్ ఎట్లా ఉంటుంది, దాన్ని ఎట్లా కంట్రోల్ చేయాలి, దాంట్లో హీట్ జనరేషన్ ఎట్లా ఆప్టమైజ్ చేయాలి అనేది మాత్రం చాలా నేర్చుకున్నాం.
ఓకే, సో అంటే మీకు ఏ పార్ట్ బాగా నచ్చింది?
మాకు ఏ పాట అంటే అట్లే అంటే ఓవరాల్ మొత్తం చేసిన అంతా ఒకటే దాని మీద కాబట్టి, సో అన్నిటి మీద బాగానే ఉంది.
ఓకే,
అన్ని కాన్సెప్ట్ అంటే ఒక్కొక్కరు ఒక్కొక్క దాని మీద చెప్పారు కాబట్టి.
ఓకే ఓకే
సో ఒకళ్ళు ఏంటంటే లైక్ థర్మల్ మేనేజ్మెంట్ ఎట్లా ఇది, దాంట్లో బ్యాటరీలో వచ్చే ప్రాబ్లమ్స్ని ఎట్లా నెక్స్ట్ ఫ్యూచర్లో ఎట్లా ఆప్టమైజ్ చేస్తాం, ఇంకా టెక్నాలజీ ఏం డెవలప్ చేస్తాం అనేది.
ఓకే, ఎక్స్పెరిమెంట్ ఎట్లా ఉంది?
ఎక్స్పెరిమెంట్ మాత్రం బాగుంది.
ఓకే, ఏమైనా నేర్చుకోరా దాంట్లో?
నేర్చుకున్నాను, లైక్ ఎట్లా అంటే ఫ్లో ఎట్లా కంట్రోల్ చేయాలి, అది చేసిన ఎక్స్పెరిమెంట్ ఎట్లా ఉంది,
ఓకే ఓకే,
మొత్తం ప్యాక్ మొత్తం ఎట్లా తయారు చేయాలి, సెల్స్ అనేది దాంట్లో స్టడీ ఎట్లా చేయాలి.
సో ఫ్యూచర్ కూడా మొత్తం ఎలక్ట్రికల్ వెహికల్ కాబట్టి, సో సో బ్యాటరీ అనేది ఒక కీ పార్ట్. సో ఫర్దర్గా అంటే నీకు ఈ వర్క్షాప్ అటెండ్ అయిన వల్ల నీకేమైనా కీ పాయింట్స్ నీకేమైనా రైజ్ అయినాయా, నీకేమైనా నోటిఫై వచ్చినాయా?
నోటిఫై అంటే లైక్ ఏవైతే ఇండస్ట్రీ ప్రస్తుతం ఇంకా దేని మీద వర్క్ చేస్తుందో దాన్ని మనం కానీ ఎట్లా మన నాలెడ్జ్ తగ్గింది, దాన్ని ఇంకా మనం ఎట్లా వర్క్ చేయాలి అంటే ఆల్రెడీ ద వే దే ఆర్ గోయింగ్, మనం ఎట్లా వెళ్ళాలి.
ఓకే 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 ఓకే, థ్యాంక్స్ ఫర్ యూ. Guys, with this we have completed our workshop and I'm very happy to take participate. Got to know more about new things about battery, and the faculty, those who delivered the lectures on the thermal battery management system, was very useful. See, in future electrical vehicle is going to be boom. In that, battery plays a major role. So whenever we draw current from the battery, automatic heat generates, and to maintain the heat generated by the battery, we need to know about this battery management system. Thanks to the Department of Mechanical and Aerospace Engineering for conducting this workshop. It was very knowledge acquiring workshop. Thank you.